This is Do It for a Living, your source for inside information on the future of automotive performance.
Everything is a learning experience, and ask the question, what is it that I could have done different that could have prevented this from happening? And it's made us more effective at doing what we do.
What's holding you back from starting or growing your business into what it can be? Well, if you're listening to this, it's not a lack of information. What you're about to hear is all you need to get motivated and start making waves. Do It for a Living podcast details the journey of today's true players in their own words. Find out how they broke out so you can too. The time is now. The time is always now.
Hey, Do It for a Living community. I'm Todd Ersley, and today I'm speaking with Sam Barros. He is the Director of Engineering at Nostrum Energy. They are a fuel injector company and has been making strides in the development of upgraded direct injectors. Now, Sam and I met at SEMA last year when he was selected as a golden ticket winner to compete in the Optima Ultimate Streetcar Invitational that goes right after the SEMA show. And he brought out his GTR, which he happens to daily drive, to have some fun with us at the Las Vegas Motor Speedway. And so he and I got to talking, and I recognized the company name from an EFI University course that I had seen about direct injection tuning. And I was even more intrigued when he and I started talking about the fact that he was working with Cobb on the direct injectors for the EcoBoost, the Ford Focus in particular. So was really excited to kind of get to know him, and I'm happy to have him on the podcast today. So Sam, how are you doing?
I'm good, Todd. Good morning. It's a pleasure to be here.
Awesome. Well, I'll let you take it over for a little bit, and if you could, just kind of tell us, what got you to this point? What got you to the point of working at Nostrum?
So let's see. I came to the U.S. About 15 years ago to pursue a mechanical engineering degree at Michigan Tech University. And up to that point, I had always known that I wanted to be a scientist. I just had this general idea of pursuing a career in research. And I was one of those kids in high school that was really involved in science fairs. So the first time I was actually in the U.S., I was competing in a international science fair. So I had a chance to visit Sandia National Research Laboratories. They showed us the airborne laser prototype and some fusion research, and I was just fascinated by the idea of living the life of a researcher. So I came here, I got my engineering degree. Somewhere along the way, I think I decided that I was more interested in being an engineer than a scientist, because scientists, engineering is applied science. Scientists just come up with new equations to better characterize something that no one's going to build anyway.
Yeah. Sometimes it can kind of feel that way.
Yeah, it was just too theoretical for me. Somewhere after physics too, I think I kind of lost interest in the hardcore science and decided to go more towards the applied side of things. So while I was a student, I did a really interesting internship at a nuclear power plant. I worked in systems engineering for the Vermont Yankee nuclear power station. And it was really neat. It was my first real exposure to professional engineering and systems, predictive engineering, trending the performance of a water pump and predicting when it will be time to overhaul the pump so it doesn't fail in service and so forth. So I kind of finished my degree expecting to have a job in an area like that, hopefully more aerospace, but somewhere in a large engineering firm. So up until then, I really wasn't that interested in doing anything automotive for a living. I've always driven cool cars, or at least I've always driven something I thought was a cool car.
Yeah.
We all think what we drive is special, but back in college, I had a 1999 Subaru 2.5 RS.
Oh,
and,
okay, yeah, very cool.
Yeah, the GC8. If you're familiar with the chassis codes, it's like the little coupe, and it came with a really anemic 165 horsepower NA engine that I blew up by doing top speed runs with the car.
Yeah.
So
What, top speed of like 78?
no, it went 138.
Oh, that's
Yeah,
much better.
or at least the speedometer thought I was going 138. It wasn't GPS verified, but it spun a rod bearing at that speed.
Okay.
And I'm really skeptical of Subaru engine longevity after owning that car, but I swapped in a EJ207 straight from Japan, and then I put a VF22 turbocharger on it. So I had a 400 all-wheel horsepower daily driver in college, and
Wow.
and it was pretty neat. But I never thought I'll be doing anything like that for a living because I didn't really see automotive as being a career for me. I mean,
Yeah, just a fun hobby, huh? Cool engineering hobby.
So when I graduated, I actually went a completely different way with my career. I moved to California, and I worked in special effects. So for a little over a year, I was a special effects engineer for a company called KVA Effects. And that company was the only company in the world that did high voltage special effects. So if you've ever seen a lightning bolt or a lightning storm in a movie with real electricity, with real lightning, that was done by that company. I've worked on Broadway. I did Young Frankenstein, Sorcerer's Apprentice, a little bit at Smurfs. I did a couple rock concerts, a Metallica show.
That's quite a shift from. I mean, I guess it's still pretty engineering based, but you're going from hardcore calculations into entertainment.
Yeah, but I mean, it was science at its very core, right? The job entailed selling, and then designing, manufacturing, and operating high voltage equipment to create these lightning bolts. So basically, we use Tesla coils. If you've ever heard of those, it's a type of high voltage transformer, and there was a very real element of danger in that, which really appealed to me because I feel like I am most focused in my job when the stakes are high. Whether it be time pressure or the consequences of not doing a good job being potentially catastrophic. So I did that for a little over a year, and then one day I was working at my desk doing CAD for a really big installation in China, and my phone rang, and the individual on the other side of the line said exactly this. He said, "Hi, is this Sam Barros?" And I said, "Yeah, this is him." And he said, "My name is Nermal Mouliea. Write it down. I want you to Google my name, and I'm going to call you back in a little bit." So
weird.
I think it was the strangest phone call I have ever received. So I was like, okay, well, how do you spell that? So he gave me the spelling. I wrote it down, and I Googled his name, and I could see that this individual had multiple patents under his name, and he owned a pharmaceutical company. So he called me back, and he said, "I have an idea that is going to revolutionize internal combustion engines forever. And I want to talk to you about this idea, but I need you to sign an NDA, and I want to meet you in person. How soon can you be in New Jersey?" So I thought this was...
Yeah, and you're living in California at the time, right?
Yeah, I was living in LA. So I had a hard time believing he was being serious, but if he was who he said he was, I at least figured that he had a real company and some accomplishments to back up his claims. So it wasn't just another crazy idea, because we do get a lot of those in our mailbox at Nostrum Energy. Everybody thinks they've got the next 100 mile per gallon carburetor car that runs on water.
Runs on water, yeah.
Yeah, what have you. But sure enough, I arranged to go to New Jersey, and I met up with Dr. Nermal, and he sat down and he said, how efficient do you think the engine in your car is? And I said, well, it's probably about 25 to 30% efficient. And he said, I think it's even less than that. And I said, well, I mean, it might be more. It really depends on at what load range you're specifying. I think peak efficiency for most internal combustion engines is in the 30s. And he said, that's garbage. Well, why do you think they're so bad? And I said, well, because combustion is an irreversible chemical process, and there are always many paths to heat loss. You're losing a lot of heat out of the exhaust and so forth. And he said, it doesn't have to be that way. I think that there is a way for us to produce an internal combustion engine that's going to be over 50% efficient. And I said, yeah, sure. I think you're probably right. I mean, very large ship engines are about 50% efficient. Once you get very large volume to surface area ratios, you cut down heat losses. Low speed engines also have lower frictional losses. And it's like, no. You have to think outside the box if we're going to do this. I have an idea that hasn't been tried before, and if we do it my way, it's going to be more efficient than any engine has ever been before. So then he explained to me how he wanted to eliminate heat losses from an engine by internally cooling the engine with water injection. And there are a few more details to it that I guess might go beyond the how technical I want to keep this discussion. But it was pretty interesting. And he said, what do you think? And I said, well, I think it could work, maybe. So he said, when can you start? And I said, well, I have a job in California. I'm interested in your idea, but I'm not really sure I want to stop working in my current company to do this. And he was able to convince me to quit my job and move to New Jersey and start working on this engine idea of his. And at the time, as I mentioned, he owned a pharmaceutical company. He still does. So we had nothing. No laboratory, no equipment, no space. I mean, it was just like me working in the same office that manages all of the pharmaceutical side of his business, with a laptop computer and a cubicle and nothing else. So my first task on the job was to find a space where we could experiment, where we could do research, come up with a research plan, identify the equipment that we were going to need in order to do these tests, come up with a thesis, the type of data that we were going to need to validate the thesis, where we could get the equipment from, how much it was going to cost, and so forth. So not a whole lot got done for about 8 months is how long it took to just create that infrastructure.
Yeah.
But we started working on it, and then we started testing it, and we saw that there was definitely an efficiency benefit to the water injection system that he had proposed. But we needed better data because we couldn't really break down all of the sources of heat loss and all of really do the full energy balance for the engine, right?
Yeah.
Where is every bit of energy going? So as we started looking at more and more advanced data acquisition systems and engines and so forth, it occurred to me that we would be a lot more successful in doing this at a laboratory that already had all the equipment. So I went back to my alma mater, Michigan Tech University, and we discussed, using some of the lab space there for the testing, and that started off a long-standing relationship that we still have with the university, where we do a lot of testing and a lot of development there. And then I guess now I'm getting to the injector bit. So what we found was that most of the water that we were injecting into the engine was not participating in combustion. So we would put, let's say, 1 gram per second of water in the cylinder. By the time of ignition, maybe 17% of that had evaporated. And we were able to see why that was by doing experiments in a combustion research vessel, where we're injecting the water at very high pressure into a high temperature atmosphere, and the vaporization rates are very low. So we knew that we needed a better way to atomize that water so it would evaporate faster. And Dr. Nermal mentioned that in the pharmaceutical side of the company, they were using colliding jets to break up medication into very fine droplets for inhalers. And that by colliding these two jets, they could get much finer droplets than they were able through other means. So he tasked me with finding a way to package colliding jets into an existing injector body. That turned out to be very difficult, but we were able to do it, and then we created several patents out of that work. But basically, we created the Nostrum injector for water injection so that we could solve a problem that we were having with poor atomization of water when using conventional injectors.
Yeah, so just wanted to ask you real quick. Water and meth injection is something, that's been around since, I remember seeing plans on it on Lockheed doing water and meth injection in like the 50s during takeoff.
Yeah,
And
absolutely.
then, lots of import, like it was a huge deal for Evos and Subarus, in the early 2000s before E85 became really popular. And now I'm seeing a resurgence again with the water and meth injection. So you guys were, did you do any research into the existing stuff? Or because those were all injected in line, like they're, in the intercooler pipes or in the intake. But it sounds like you guys were doing it directly into the combustion chamber.
Yes, and also for a different reason. So if you look at water methanol injection in turbocharged engines or the first instances of water methanol injection, which were back in World War II for supercharged piston-powered airplane on takeoff, it was being used for NOx suppression by basically cooling down the intake charge. So you've got a boosted engine, it compresses the air heats up, and then the hot air during compression inside the cylinder eventually becomes hot enough to auto-ignite the air-fuel mixture, and you get detonation. So they were injecting water to cool down the air so that they could prevent detonation from occurring. We were injecting water to keep the heat in the cylinder. So essentially, we weren't trying to fight NOx so much as we were trying to lower the overall temperature of the combustion event so that we could reduce how much heat was escaping the engine. So it has to do with running the engine in a different regimen. We were running the engines either very lean or with no fuel enrichment under boost, a very high compression ratio, very high water jacket temperatures, which is something you'd never really want in a boosted engine because it tends to make the knock issues worse. But yeah, it was it's a similar system, but being used for a different strategy.
Gotcha. Yeah. So you guys were focusing more on efficiency and not, performance gains.
Exactly. Yes.
Much.
It was entirely done to improve efficiency and not to improve power output.
Okay. Very cool. And so this, that relationship with Michigan State University. Was that correct?
Michigan Tech.
Okay, yeah. So that relationship with Michigan Tech, I'm assuming that was a pretty good one because, being in Michigan, did they have a really big automotive development department?
Yeah, absolutely. I mean, if you look at what we do there today, we have access to a combustion research vessel, a single-cylinder engine, an optically transparent single-cylinder engine. So it has a sapphire piston and quartz cylinder liner, so we can actually see through the engine as the fuel is mixing with the air and burning, and then we can understand the interaction of our injector fuel spray with the airflow.
That's pretty wild. That's pretty wild sounding.
And we run 2 dyno cells. So we have a 6.7 liter turbo diesel, and we have a 2 liter turbocharged direct injection gasoline engine. We keep a staff of engineers full time there. We have our own office at the research laboratory. We hire multiple graduate students. We have access to staff. We have some of the staff in our advisory board, and we publish several papers every year coming out of the research there. So it's like being a research institution without the cost of having to buy all the equipment yourself.
Yep. And so sorry to get us kind of off kilter here, but take us back through into actually kind of shifting gears from water injection into fuel injection.
Yes, of course. So we have this water injector, right? And it works great, but it has cost a lot of time and a lot of money to produce this injector. And there really isn't a huge market for it because, well, no one is doing direct water injection outside of the laboratory. So
because you'd have to retrofit quite a bit of equipment to put that on a vehicle.
Yes, exactly. And the other thing is right around the time that we had perfected that injector, the cost of fuel started to drop. Mm-hmm. So now it becomes less of an attractive proposition to do major surgery to a vehicle to improve fuel efficiency when you're really not spending that much money on fuel to begin with.
What was the improvements that you guys saw? Did you get any hard data on fuel efficiency improvements?
Yeah, absolutely. So in the case of the turbocharged 2-liter gasoline engine that we run in the laboratory, high load fuel consumption went down by over 25%.
Wow.
So, I mean, that's quite dramatic. And it's a really big opportunity for downsizing because the problem with downsizing today, and not to pick on any one manufacturer, but if we just borrow the EcoBoost F-150 as a case study, right? Mm-hmm. It has a very good EPA fuel economy rating. It's supposed to get, I think, 23 mpg. But the real world observed fuel economy is very poor. It's the root of a lot of customer complaints. And the reason for that is that turbocharged engines are only good on fuel when they're not running under boost. Once they start to go into boost, you're forced to retard ignition timing and also enrich the air fuel charge for NOx suppression. So as soon as you do that, the engine efficiency plummets. At full load, you're not running lambda 1 anymore. You're running, lambda 0.8 or 0.76 or something like that. All that extra fuel is just being used to cool the intake charge, suppress NOx, and going out the tailpipe as wasted energy.
Yeah.
When you're able to do away with that using water injection, you can go back to running lambda 1 all the time at MBT timing. You essentially have peak efficiency everywhere in the high load range.
Gotcha. Gotcha. Yeah. So that's why, I see the, is it Chevy or Dodge or both that has the cylinder cut? They're taking advantage of big displacement when needed and then low displacement on the highway. And so that's how they're able to get so much better fuel economy all around is kind of what it seems to be.
Exactly. And then what the cylinder deactivation is doing is it's increasing engine load because engines are most efficient at about 80% of maximum power. And this makes sense if you think about what the engine efficiency is at idle, right? It's 0.
Mm-hmm.
All the fuel you burn gets turned into gets used up overcoming friction to just keep the engine turning over. So as you leave idle and you go from 5%, 10%, 15% off maximum rated power, the efficiency is awful, single digits. And then as you near max power is really where the power output versus power loss in friction starts to be very, let's say, beneficial. Mm-hmm. So that's where the engine is making most of its efficiency. So what you can do is if you virtually half the engine size, then you have to double the power per cylinder in order to keep making the same power. So you're now operating at a much higher load range where the engine is a lot more efficient. And that's why cylinder deactivation is good on fuel.
Yep. Okay. But yeah, so getting back again to the injectors, so you did get really good results from that, but just it's the market couldn't withstand the changes needed, especially in the aftermarket side, post-production to retrofit a vehicle for 25% increased efficiency when gas was $1.50 a gallon or.
Right. But it is still a business for us. It's just it's an OEM business now. In other words, we are working with auto manufacturers on advanced concept development, so that this would be an OEM technology. It could be something that you might see in a car or truck several years down the line, but not a retrofit. So, and obviously these research programs don't really move a lot of injector volume, so it's not very profitable to do things that way for a very long time until you actually have a product in the market. So we have an injector. We don't have a lot of customers for it, and I said, you know what, we've spent a fortune developing the technology to create our own direct injectors. No one else is making direct injectors right now except for the tier 1 suppliers, Bosch, Delphi, Denso, so forth, and they're not interested in making high flow rate direct injectors. So why don't we come into the aftermarket and we offer a high flow rate direct injector? Because right now, if you have a port injected car and you want to make a bunch of power, you have multiple manufacturers that will sell you large PFI injectors that will meet your fueling needs, well past 1,500 horsepower. But if you have a DI engine, when you run out of injectors, you're done. There's no, that's it. There's no fueling solution. And then you have a lot of people who are doing like methanol injection as supplemental fueling, or port fuel injection retrofits, and these are just the PFI retrofits are not that bad. I guess if you're gonna think of the good, the bad, and the ugly, the port retrofits are bad because the ECU is not under full control of fueling, but they're not terrible. Methanol injection as supplemental fueling is the ugly. You have like a weed sprayer that's just hosing down the intake with methanol. You're hoping that it's going to sort of distribute equally amongst the cylinders.
But you really don't have any idea.
Exactly. Yeah. And a lot of people lose engines like that. I identified this opportunity to come into the aftermarket making high flow rate direct injectors, and we started doing that. We launched it at SEMA 2 years ago with just a couple products. I think we had the GM Ecotec. I think we had the BMW N55 and Audi, Volkswagen EA 888. Now we've expanded it into the GM LT, and we've got EcoBoost 3.5, 2 liter, 2.4, and we're continually expanding the product line. We hope to be doing Subaru, Porsche, and some more Audi, Volkswagen engines this year. And it's paid off because the injectors, especially when paired with a fuel pump of sufficient capacity are good for a little over 150 horsepower per cylinder. So we've seen very good results, and we have a Cadillac ATS 2-liter turbo demo vehicle now that's got about 40,000 miles on the injectors. They run great. It cold starts and idles like a factory vehicle, and it has enough fuel headroom to support 600 horsepower from a 4-cylinder engine. So it's pretty good.
Oh, very cool. Yeah, and so that's the one I see in pictures with the EFI University school. Is that the one that you use for that class?
Yeah. We own the vehicle, so it's a good candidate for us to loan out to EFI University, or we also do a lot of tests and research on it. We did emissions testing because for some markets that can be an issue.
Did you have to get them CARB certified?
The injectors themselves are not. I'm not the expert on CARB certification. Frank would be the better person to talk to about that. But my understanding is you have to certify everything up to and including the calibration. Yeah, but the big question for us was, are the injectors doing anything to emissions that would make it impossible to pass emissions with the vehicle? Because with a lot of other high flow rate fuel injector solutions, you end up with very large fuel droplets, and large fuel droplets tend to generate soot, and soot will make you fail emissions. So that was really the root of our emissions testing, what we're really looking for there. Gotcha.
And is that Cadillac, is that a forced induction car?
Yeah. It's a direct injection, variable valve timing, turbocharged, 4-cylinder. Has a pretty high-tech turbocharger too. It's got a Borg Warner. I think it's a twin scroll.
Tell us a little bit about the pumps as well. So are you guys making the fuel pump, the high-pressure fuel pumps as well, or how are you retrofitting those?
So we don't actually make the pumps, but we work with 2 partners that do. So for the LT engine, Lingenfelter has a 12 millimeter plunger pump that's capable of supplying over 1,200 horsepower, or about 1,200 horsepower worth of fuel on gasoline. Mm-hmm. And then for other applications like Ecotec, Volkswagen EcoBoost, we work with another company that does fuel pumps for those vehicles.
Okay, so you're able to offer, as this comes more and more available, a package for people wanting to upgrade their vehicle.
Yes, and we offer them through our website.
It's pretty crazy to hear the story that, you started. Well, I mean, the main question that comes to my head is, how did that guy even get a hold of you? Like the initial communication, like how did he even get your number?
Well, that's interesting. So, as I mentioned before, I was very involved in science fairs when I was in high school, and I had a website about that work, Power Labs. It's still up. I haven't updated it in a long time. But on that website, I basically put reports on the scientific experiments that I did. And he was looking for work with water injection, and I had done work with water injection that I put up on my website. So I think the website came up on his search, and he thought I might be a good person to talk to.
Wow. Yeah. Funny how things happen that way, huh?
Yeah. It's the website has actually paid off quite nicely, not financially, I mean, in terms of opportunities. The Discovery Channel found out about me through the website, so I got to be on a couple episodes of different Discovery Channel shows. Junkyard Wars, back in the day. I remember
that one, yeah.
Yep. So they found me through my website, and I got to be on that show as well. And then,
very cool. Oh, man. What was the were you part of one of the projects?
Yeah, I was. We had to build machines to carry water over off-road terrain. So we fit a truck axle in the bed of a truck, and we put 2 buckets on it, and we powered it with a motorcycle engine, so the buckets would spin like a giant centrifuge to try and hold the water in that way. It didn't work, but it was fun.
Yeah, you tried though, huh?
It was not my idea. In my defense, I didn't come up with that idea.
That's a good in theory though, but just didn't pan out, huh?
It was super dangerous. I mean, I was just waiting for one of those buckets to fly up and hit someone.
I'll have to see. We'll have to see if we can find that episode and post it up somewhere.
Yeah.
Yeah. So, is there anybody else in the direct injector market? Sorry, in the aftermarket direct injector market? Is there, somebody that's also trying to do this to compete with you guys? Or are you kind of paving the way solely with this project?
So there is another company that they take factory injectors and they drill another hole in the injector. I think that in the PFI world, you see a lot of that as well, right? The decapping injectors, they buy OEM fuel injectors and they just grind off the spray plate, so that the injector can flow more. It's certainly a much easier, cheaper proposition than trying to design an injector to flow more from the get-go. But in direct injection, that doesn't really work for two reasons. First of all, there is a limit to how much fuel you can flow through the injector body itself, and it's governed by the opening stroke of the solenoid, basically how far the pinto lifts above its seat to allow fuel to flow, right? So if you don't increase that opening stroke and you just drill more holes or bigger holes in the nozzle of the injector, you get an injector that flows more fuel at low pressures but doesn't flow anymore at high pressure.
Yeah, because the out is bigger than the in, huh?
Yes, exactly. So, but yeah, some people are doing that. I haven't seen any results. I'm not one to bash my competition, but I believe that until the industry becomes a lot more sophisticated and they start doing what we're doing, which is re-engineering the injector internals, re-engineering that opening gap, we're not really going to see anything that can do what our injectors do in terms of flow rate.
So does this mean that you guys are actually manufacturing your own injectors?
Yeah, so for PFI, we make the complete injector, everything from the body mold, connector, everything else.
So you're not buying like Bosch injectors for your port, you're just normal injector?
Correct. So we are an injector manufacturer. We're very unique in this because everybody else either decaps factory injectors or resells Bosch Motorsports injectors. In the DI world, we start off with a Bosch HDEV5 injector, and then we re-engineer the injector. So all of our intellectual property, all of our patents are in the nozzle. So that's the component that we fabricate there.
And I've seen, doing some research on your company, you guys also have like a split spray pattern. I don't know what the engineering term for that, what you guys call it, but is that something unique for you guys to spray the fuel directly into each individual port?
It is unique in the aftermarket, but not in the OEM world. So that's actually something we're really excited about. We launched it at SEMA this last year, and it's our first foray into port fuel injection. So after we had the direct injectors and we started operating in the aftermarket, we thought it would be really interesting to see what we could do with PFI. And if you look at how port fuel injection is done today, aftermarket, high flow rate port fuel injection, the injectors don't have spray plates anymore. So the solenoid opens and you just have this solid slug of fuel that comes out and it hits the intake port divider, because most engines today are 4 valves. So you've got 2 intake ports. There's this divider right in front of the injector. The fuel hits the intake port divider, splashes everywhere on the intake port, and then starts evaporating off the intake port. And as it evaporates from the intake port, that fuel vapor then displaces incoming air. So there is a certain loss of volumetric efficiency associated with that. That's one of the big reasons why direct fuel injection is able to make a lot more power than port fuel injection, because you're not displacing incoming air, so you have higher volumetric efficiency. And there are also knock mitigation benefits. But most OEM injectors are spray targeted and typically also split gamma. They try to avoid impinging fuel on the intake port divider. And what we've done is we've taken that OEM concept of spray targeting and split gamma and brought it into the aftermarket as high flow rate injectors. So we can make up to 1100 cc per minute injectors that still use our colliding jet mechanism. So we still have very small fuel droplets, but in two separate sprays, and the two sprays are both aimed at the back of the intake valve. So that we're mimicking the OEM injectors spray pattern. That means that a lot of the transient fueling is spot on. So cold starts, E85 idle, low speed drivability is all a lot nicer. It drives a lot more like a factory car.
So your only concern there is in user installation. You get that thing cocked 90 degrees and you're kind of hosed.
Yeah, absolutely. But the nice thing about being an injector manufacturer is that we can mimic the OEM outline.
Yep.
So the factory clips are reused, which means that the injector locks in place the same way the OEM injector does.
Gotcha.
We have no spacers, no pigtail adapters. Everything is just like the OEM injector.
Got it. Yeah, just thinking it would be really bad if the user was able to rotate it, but obviously you guys have thought about that.
Of course, yeah, that's certainly a big concern.
And so, geographically, your location, as you mentioned earlier, has been pivotal in your research and design, being able to team up with a university that's got the machinery that you need to use. But what do you think about the location as far as like the business success? Does it put you, are you in a good market for, advertising the company, or, do you have to travel a lot to visit clients, around the country?
Yeah, I travel a tremendous amount. I usually go to Germany 3 or 4 times a year, 1 or 2 trips to the UK. The aftermarket tuning companies are all over the country, right? So being here in Michigan, we're close to Lingenfelter. We've got a really good relationship with them, but Cobb is all the way over in Austin, and then some of the other guys are in South Carolina, and some people are in California. I travel a lot. I believe in face-to-face business. I like to know the customer, what they need, explain to them why we do things the way that we do, and collaborate. We are a very science-based company. We have the tools and the know-how to do a lot of high-end development that's typically not seen in the aftermarket. So I always like to take my customer requests and turn them into research projects. Like how can we identify idle stability issues, and then how can we improve them, and how can we test that in the laboratory. So I travel a lot. The reason for being located in Michigan is because of the OEM end goal. We are an aftermarket company, but we strive to be an OEM supplier. And if you want to do anything with OEMs, it really has to be Detroit Metro. That's where all the big 3 are, and the tier 1 suppliers and the tier 2s, and we also subcontract some testing, like the emissions testing, for example.
Yep.
And all that stuff is located in Detroit Metro as well. So it's good for that reason.
Gotcha. With developing this business, it sounded like you were kind of single-handedly put in charge of this whole water injection, and then now the direct injection. So tell us kind of something bad that's happened, something unexpected that happened that really kind of threw you for a loop. And then what did you do to kind of get over it?
Well, I mean, I was the first person on board, but we have a much bigger team now, and we have Frank Loscudaro, our VP. He handles all of the suppliers and contracts and everything else, so I don't have to deal with paperwork, which is great, because I hate it and I'm not very good at it. We have a full-time engineer, Nag Piduru, whose only function is the CFD side of things. So all the spray targeting for the injectors is done by him. Up at Michigan Tech, we've got an entire team. We have Bill Atkinson, our R&D manager. He runs the laboratory, and we've got Brian and VJ who run all the tests in the lab. So I'm by no means single-handedly doing all this. My coworkers take the bulk of the credit for really making it happen. I think my biggest part in the project is turning the ideas, the concepts into prototypes. That from there, getting the prototypes into a product is really everybody else's role. Disadvantages to being here, we've had many. Everywhere from trying to make the injectors work. For a while, everything that we made was a learning lesson. Like we would make injectors and they wouldn't fire, and we had to figure out why. So had to learn different means of a non-destructive testing, figuring out what was happening inside the injector. And then when we had injectors that worked, they wouldn't quite work the way that we wanted them to. So trying to figure out why that was the case, and all along that process, the parent company that funds all this has been very understanding. So I'm really grateful for that. Beyond the laboratory failures, on the business side, a lot of times you work with companies that you think they are, let's say, on the same level as you in know-how. A lot of times companies do a really good job of marketing themselves as being like this high-tech, we can make it happen type of attitude.
Yep.
And then when you start working with them, you find that that's not necessarily the case. So we've had a couple disappointments, but everything is a learning experience, right? So I always like to blame myself and ask the question, what is it that I could have done different that could have prevented this from happening? And it's made us more effective at doing what we do. So I wouldn't do it different.
Very cool, man. Yeah, it's I assume there's a lot of headache involved with engineering products like you've got. So, you're going to come into struggles often with the development of something this critical.
Absolutely. Yeah, I really wish I could just buy someone else's injectors, box them up, and ship them. It would make my life much easier.
Yeah. So, enough with the bad stuff. It's pretty typical of an engineering firm to, run into issues like that. But what's something right now that, has got you really fired up? Is something you're excited about for this year?
On a personal level, I am just thrilled to see my car modification hobby, become a job. I can invoice dyno time on my GTR. Nice. Think about that. That is ultimate job satisfaction. I can literally come into the office and say, hey guys, this Thursday, I'm going to be gone all afternoon. I'm going to be on the dyno. And I'll get a set of prototype injectors, slap them in the car, run it on the dyno for 5 hours, do whatever I want, try different calibration strategies. So I get to learn a lot, and I'm becoming a much better calibrator as a result of that, which is something that I really appreciate because it's one of my personal goals. I enjoy calibration, and I want to be better at it. And the results are great. I pulled a set of 1300 cc per minute injectors from the GTR, swapped in one of our prototype injectors, and picked up 36 wheel horsepower. So these are big victories. It's really special when something that was just an idea in your mind a couple years ago becomes a product and works, right?
Oh yeah, yeah.
We're also working with race teams, and Obviously, I'm not at liberty to discuss who or what, but these are some of the most exciting projects that I've ever worked on, and the race industry is so fast-paced and competitive, and if you've got something that gives you an advantage that no one else has, people get really fired up about it, and you get to work with people who really value your contribution and are really interested in what you're doing, and they help push you, to get things done faster. So I like the pace and I like the excitement associated with racing.
Have you guys tried to approach any of the F1 teams, to try to improve? This gets back into the water injection side, but even on the fuel injectors, like improving efficiency there, because that's been a big push the last couple of years. Those cars are up to, I don't know what the number is, but it's around 50% efficient. Do you know where they're at now? Because it's crazy high with the KERS and the electric motors and everything that they've got in them. But I think it'd be pretty cool if you guys are working with some of the F1 teams on doing maybe even the water injection kit on there.
Yeah, well, I bolueve water injection is specifically banned in Formula One because they did use it back in the turbo days before they switched to a toluene-based fuel. But yeah, the answer to your question, have we tried to approach the Formula One teams? We haven't had to, and I have to leave it at that.
Okay, gotcha.
We haven't had to approach them.
Gotcha. So I wanted to get talking more about your strategic partners. I mentioned in the opening, and we've talked about it a little bit with EFI University and some others. Can you tell us about what you guys are doing with some of these other companies to kind of spread the word about your business?
Yeah, sure. So obviously we have a great relationship with EFI University. Myself and some of our engineers spent a whole week there creating coursework for a direct injection calibration course that's actually being taught this next weekend, April 1st and 2nd. We work very closely with Lingenfelter. We have a really good relationship with them. Nostrum Energy sees Lingenfelter as one of the leaders in the LS LT world, and they've really helped us take our LT injectors to completion. We had a pretty good concept that we ran on their dyno, and working with a company like Lingenfelter, you get so much more than just a dyno printout, right? They have combustion analyzers, and they have engineering know-how that really gives us the kind of data we need. Also, we have a pretty good relationship with Cobb. I've spent some time in Austin on the dyno with those guys. Cobb is another world-class engineering-based company, so we're really excited to be working with them. We've worked with a lot of the other usual suspects in the industry. I think if you did a Google for, let's say, who's the biggest tuner for Audi, Volkswagen, who's the biggest tuner for EcoBoost, we've been there. Yep. I don't know who all I can talk about by name.
That's okay.
So
you're trying to get all the big players involved with your product.
Yeah, and it's a collaboration. So I'm not trying to sell injectors to these guys. I'm trying to say, okay, so what's your biggest seller? What's the platform that you guys are most interested in? Where does it run out of fuel? How does it run out of fuel? Is it running out of high pressure pump? Is it running out of injector? Both? Is the in-tank pump sufficient? And what can we do to overcome those limitations? So I think they learn from us as much as we learn from them, and together we come up with these fueling solutions, and we've got a couple that we've finished so far, but we have a lot more that are still coming.
So what's been, so far the most successful way to promote your business? So, I've seen you at trade shows, but, other than that, I haven't looked out for you too much as far as marketing or, going to meets and stuff. What's kind of worked best for you guys? And then what is your plan moving forward?
Trade shows for sure. I mean, you go to a place like PRI or SEMA, and you basically you get to meet the who's who of the industry. I mean, I will never forget being at the booth at SEMA last year and seeing people that I had looked up to since my college days of modifying Subarus
Yeah.
come over and say, hey, we wanted to talk to you guys about your fuel injectors. And it's a great experience. And like I said before, I love face-to-face business. I like getting to know the customer in person. So that's my favorite. PRI was very good for us. It also exposes to markets that we hadn't even thought about trying to operate in, like Dubai, for example. I went to Dubai early this year to meet some people that we had met at PRI. So that was a really good opportunity. I know there are other venues that you can go to get the word out. For example, Facebook, internet forums. We're somewhat active on that, but it's not as enjoyable for starters. And the reason is you come into an internet forum and you say, hey, we've got these spray-targeted split gamma injectors, and I'm running them on my car, picked up 36 wheel horsepower. Here's how they work. Right away, there's just a torrent of negativity.
Yeah.
I'm sure you know what I'm talking about. I've been on the forums for a long time. I was on the NASIOC and the Corvette forum, and I'm on the GTR forum as well. And I learn a lot from them as an enthusiast. It's always a good place to go to and find how-tos. How can I change my oil? What torque do I torque my spark plugs down to? But it's really hard to have a good technical conversation there because there's so many. What's the word they like to use? Trolls, right?
Yeah.
So I think we could do a better job of increasing our presence on those venues, but it's tough. It's aggravating. It takes time of my day to be there trying to answer questions, and then when people come in and they just want to bash your product or like detract the conversation, it's hard to justify the time spent.
Gotcha. Well, so what is your 1 year plan for the business? Kind of where do you want to see Nostrum Energy by the end of this year?
I think a big win for us at the end of this year will be if we get all of the new products that we're developing out by SEMA. The 1 year plan really is to increase support for new platforms. We want to bring in LS injectors. We want to do Porsche. We want to do some of the Audi, Volkswagen 6-cylinder, 8-cylinder, 10-cylinder engines. The Subaru guys are always badgering us to get them injectors, so we want to get that out. Maybe Mazda Speed. That's a pretty vocal crowd as well. So just increase the product portfolio is the 1 year plan.
And then what about a 5 year plan? Can you think of some kind of farther down the road goals for the business?
Yeah, I think it's split up into two separate aspects of the business. On the research side, we're going to keep pushing for the high efficiency OEM focused water injection research and continue growing that with OEM partners. So I would really like to see that become a production intent project at one of the OEMs. On the aftermarket, I would really like to be more of a fuel solutions company, not a fuel injector company. So right now we've got the DI and the PFI injectors, and we're working with some people on the high pressure pumps. Eventually, in 5 years, I would love to be able to offer you a complete fueling solution to your vehicle. In-tank pump, fuel rails, our own high pressure pump, perhaps. Everything you need to achieve your horsepower goals.
Gotcha. Very cool, man. Yeah, that would be really exciting to see.
Yeah.
And so kind of do in this here, we'll ask some quick answer questions for you. So Tell us about a game-changing product that you've seen in the last year. Something that either you guys are coming up with, or something you saw at PRI or SEMA that you really liked.
For me, it's any time calibration support comes out for a new platform, right? Calibration is everything. Until Cobb cracked the GTR, nobody could do anything to them. You'd put like downpipes on the car, throw a check engine light, and it would run like crap. So yeah, any new calibration support, the SCT support to the EcoBoost and new vehicle support from HP tuners, that's always a game changer. As soon as the calibration support is there, everything else follows.
Yeah, we recently had Thad Norman of Hypercar Development on here, and he was discussing the calibration support that they're coming up with for the McLaren platform. So,
oh, that is exciting.
Yeah, that's a pretty crazy one.
Yes.
So what software programs are you using daily in your business?
So other than the usual ones, right, Microsoft Excel, PowerPoint, Word, and everything else everybody else with a computer uses, I use SolidWorks a lot. So all of the CAD that we do is done in SolidWorks, and then we use a CFD tool within SolidWorks that's called Flow. And it does single fluid CFD. So with Flow, we can predict fuel injector flow rates before we ever drill any holes. We also use a tool called Converge from Convergent Sciences. It's a $40,000 a year license to have that. And it runs on a 32-core supercomputer that costs another 20 grand. But what Converge does is it is able to do mixed fluid CFD. So it is actually able to predict the airflow and the interaction. Injector. Yeah, exactly. And the interaction of the fuel with the air in the engine. So that's how we do all of this spray targeting work. These are the two biggest ones. On the calibration side, I use HP tuners, EFI Live, Ecutech, Axis Tuner, Winols, and I'm learning Motec. And I will typically use almost all of those on a every 2-month basis or so.
Wow, very cool, man. What about your favorite shop tool when you're out working in the shop? What's something that you really like to use?
My oscilloscope. So I have a Tektronix 204 portable oscilloscope, and it is the best money I have ever spent on any tool. I mean, you have an electronic related question, that tool has the answer. It has a Hall effect current clamp, which is a really, really small current probe. You just clip it over a wire, and you can see what the signal looks like. So if you know what you're looking for, you can even tell whether an injector is opening after it receives the electrical signal or not. For tuning, you can increase ignition coil dwell time and identify when you're reaching saturation. I can look at the crank position sensor signal to see why I'm losing sync. I can look at everything with storage and data analysis. So I don't work on any cars without that. Without
your oscilloscope, huh? You take it with you everywhere.
Everywhere. It has its own little briefcase, nice and portable. It went with me to Dubai, and then the guys at the shop in Dubai are like, "Wow, what is that?"
That's cool.
It causes quite an impression. It's a really high-tech tool, so I love it.
And what are you daily driving right now?
I daily drive the 2014 Nissan GTR that you saw me racing at the Optima Challenge, and I have a daily driver tune that's not quite as hot as the racing tune. But yeah, I even drive it in winter. I have a set of snow tires for it, so it's a true daily driver.
How many miles you got on it now?
I bought it a year and a half ago with 8,500 miles, and I think I am going to cross 50,000 this month or the next.
Yep, so it's definitely putting a lot of miles on that thing, huh? And it sounds like lots of dyno miles as well. Yeah,
I figure I've got about 9 hours on the dyno with it so far.
Well, where do you see the future of automotive performance going? You're going to be a pretty good steward of this, so kind of where do you see things going?
Yeah, that's a really good question. I've had an opportunity to discuss this with some of the people that I really look up to in the industry on the calibration side of things, because calibration is so important. As you know, if you can't tune it, you can't modify it. I think, and this is mirrored by some of the people that I spoke to, that it is very possible that ECUs will become too complex, time-consuming, and encrypted to calibrate within the next, let's say, decade or so.
Mm-hmm.
There are already vehicles that no one has been able to hack the ECU on, some German cars, some Mercedes-Benz, and it's possible that maybe a car will come out in 10 years that everybody wants to tune, but nobody can because the ECU is unhackable. So what does that mean to us, right? Does that mean that in the future our hobby of modifying cars will go away? I don't think so. I think that standalone ECU replacement solutions are going to become more and more sophisticated. The guys at Cyvex and Motec already make some incredible drop-in replacement ECUs, and I think these tools are only going to get better. So it's going to dramatically increase the price of entry. It might be that 10 years from now you can't buy a new car and just reflash it and pick up 100 horsepower anymore. You're going to have to replace the ECU. But then when you do that, then you have a lot better possibilities for calibration. So that's one of the things I think could happen. The other one is hybridization is here to stay. We're hearing rumors of the next GTR potentially being a hybrid. The Porsche 911 Turbo is supposed to be a hybrid, the next one. It is possible that soon in its development path, the Corvette will be hybridized, maybe the next ZR1 or the ZR1 after that. And hybridization also has a huge potential for the aftermarket if we can figure out how to tune it. Because you can really change torque limits and current limits and get a lot more performance out there. So I think, generally speaking, where I see the aftermarket going is the price of entry may rise, but with it, so will the potential gains. And then on the fuel side, I think PFI-DI strategies are most likely going to be the future path of fueling for the industry. And the reason for that is mostly emissions, interestingly enough, and it's not coming from the US, which is why the potential cutbacks for the EPA are not going to impact us. Mm-hmm. Automakers are all global now, even if General Motors was free to run whatever fuel system they wanted, even if the EPA disappeared and we could start selling catless cars in the United States. Yeah. Everything comes with an open downpipe and a 4-inch exhaust. It wouldn't matter because Europe is a big driver of sales, and European emissions are very stringent, and they're very stringent in particulate matter for gasoline engines. That's just coming in now, and it has huge implications for engine architecture. Direct injection generates fine particulate matter, and it is generally believed that these are insurmountable challenges, that it's not going to be possible to do a DI-only system that's going to meet PM emission certification levels in Europe. So they're doing a lot of PFI-DI systems for that reason.
Just like the Subaru BRZ.
Like the BRZ, car, yeah. The new EcoBoost, the whole EcoBoost line is PFI-DI now. The 3.5 V6 is PFI-DI in the Raptor, but it's going to be on the trucks as well. The V8 is PFI-DI. We're going to be seeing. I guess I can't talk about upcoming vehicles, but let's just say most.
Yeah, it's going to be more of them, huh?
Yeah, it's going to be more of that, and it's mostly for PM emissions. Vehicles that are staying DI only, like Mercedes-Benz, they run GPFs. So anyone familiar with diesels is familiar with the DPF, the diesel particulate filter. We now have gasoline particulate filters in some vehicles, and they do cost horsepower in terms of back pressure. So for high performance applications, the PFI DI is a better solution. So we'll be seeing a lot more of that. Very, very interesting insight. We appreciate that. And so how do people connect with you and your company? You know, how do they find out more information about it? So Nostrum Energy is on Facebook. We are on Instagram. We're on Twitter, but we don't have a lot of followers there. Facebook is really a great way to get a hold of us. You can also go to nostrumshop.com to see our current product lineup, and you can email us there, or at nostrumenergy.com, and everything goes to a central email address that then gets distributed to whoever the message is intended for. Awesome, man. Well, I really, really, really appreciate you taking some time with us. Got a lot of great insight, and it's really cool to hear about the company and, you know, kind of how you came up with it. So thanks again for doing an interview with us. Thank you. It's been a pleasure.
Thanks for listening to Do It for a Living. You can find out more about this guest, this show, and even details about what we just talked about at our website, doitforaliving.net. Check out the Facebook page at facebook.com/doitforaliving and tell us who you want to hear from. And most importantly, subscribe to the podcast. Click subscribe. Do it now. Seriously. I'll wait while you grab your phone. Open up the podcast app. Tap the subscribe button. When you subscribe, you help us gain momentum and attract more high-level guests.